Bismillahirrahmanirrahim. Assalamu alaikum, my dear student. I am your instructor, Engineer Hassan Khan, and this is 8th lecture of Engineering Hydrology. In this lecture, we will discuss the last method of calculating average precipitation over a basin, the Isohytal Method. You know, the average precipitation over a basin we have discussed two methods in the previous lecture. One is arithmetic mean method and the second one is decent polygon method. And the last and the third method of this average precipitation calculation is Isohytal method. In the first method, the arithmetic mean method, it is very simple method and it is applicable only in a condition when the precipitation over the area is uniform and when the precipitation gauges in the area is distributed uniformly, which is only possible in flat region, in plain areas. So it means that a simple arithmetic mean method is applicable only for plain areas. The other two methods, that is decent polygon and the Isohytal methods, are very accurate method, and in these two, the last one method, that is Isohytal method, is the most accurate method of measuring average precipitation over a basin. These both methods are applicable for hilly areas as well as for plain areas. So let's discuss the Isohytal method. This is method number 3, So it is the most accurate method of averaging precipitation over an area. So isohyte, in the name, the isohyte means a line joining points of equal rainfall magnitude. This is just like the contour. Contour is a line which joins points of equal elevation, reduced levels. Here isohytes is a line which joins points of equal rainfall. For estimation of average precipitation of the catchment by Isohytal method, the following steps are used. These are now the steps. The first step is draw the given area according to certain scale and locate the station where precipitation gauges are located. So this is, let's suppose, the area, the catchment area, and these are the stations. Locate these stations. The second step is to write down the amount of precipitation for each station. So write down the amount of, like this is a station and the precipitation amount at this station is 25 millimeter, at this 33 millimeter, at this 40 millimeter, here it is 38 millimeter, here it is 30 millimeter, and it is here as 44 millimeter. So the next step is draw isohytes. Now in this area we have only 6 points whose precipitation values are known. Now we will do we will interpolate these points throughout the area, and by interpolation we will find different points in this area whose precipitation will be calculated from the interpolation. Like these are the 2 points, 44 millimeter and 30 millimeter. We will interpolate between these 2 points various points like 40 millimeter point, 35 millimeter points, and similarly all these points are determined, just like preparing a contour map, as you already have known about the contour map. Contour map we have already discussed in the survey game, in the last survey game. So what we will do then, draw isohytes, mean draw lines which join points of equal precipitation, just like this. Now this is a line This line is known as isohyte, and the value of this isohyte is how much? Of 25. This is 25. Similarly, this is another isohyte and its value is 30. Here it is an isohyte whose value is 35. This is an isohyte whose value is 40, and here it is an isohyte of 45. Remember, all the points at these points, all the points at these lines, joining these lines, having same precipitation of 25 millimeters. Similarly, here all the points having same precipitation amount of 30 millimeter, and it is 35 over this line. Okay, now we have isohytes. Remember, the difference between any two isohytes should be constant, like this. This is the 25 millimeter and 30 millimeter, and similarly 35. So how much is the difference? The difference is 5 millimeter. So now here at the starting point, this boundary, we don't know the value of this, and similarly at the end, this boundary should be known. So what we will do for this? For the value of this boundary and this boundary, normally what we will use? We will use the same amount like of the first isohyte. The value of the first isohyte is 25. We will also assume 25 millimeter of rainfall for this boundary. Similarly, the value of the last isohyte is 45 millimeter, so we can assume the value of 45 for this boundary line. Okay, then measure area enclosed between every two isohytes, or the area. These are the two isohytes, isohyte number 25, isohyte of 25 millimeter, and isohyte of 30 millimeter. So measure this area, or sometimes the area enclosed by an isohyte and boundary of the catchment, like this, like at the first and at the last. This is an isohyte and this is the boundary. So measure all these areas between the two isohytes, or between the isohyte and a boundary. Just like this. This is area. Measure this. As you know, this area can be measured by various methods. We have already discussed those methods in the Thiessen polygon method. You can measure it by a tracing paper. You can measure it by planimeter, or any other method. You can measure the area. Okay. After measuring the area, what we will do? We will calculate the average precipitation by the formula of the Thiessen polygon, and the formula of the Thiessen polygon is just similar to that of the formula of the Isohytal method is just similar to that of the Thiessen polygon method, in which P average is equal to P1 into A1 plus P2 into A2 plus P3 into A3, and so on up to the Pn into An, and then divided by capital A. But the meaning of these terms in the Isohytal method is different, while in the Thiessen polygon method is different. Here the P1 mean, in the Isohytal method, by P1 we mean the precipitation of station 1, but here in the Isohytal method, by P1 we mean the mean precipitation of two isohytes 1 and 2. Similarly, P2 will be the mean precipitation of other two isohytes, that are isohyte number 2 and isohyte number 3, and P3 will be the mean of other two isohytes, that are isohyte number 3 and isohyte number 4. Similarly, Pn will be the mean precipitation of isohytes number n1, n-1, and isohyte number n. And all A A1, A2, A3, A4 up to An represents the area between these isohytes, and capital A in the denominator represent the total area of the catchment. You can understand by this formula, like let's suppose this is one isohyte, okay, and this is another isohyte. So what will we do? We will find the average of this boundary and the isohyte number 1, which is 25, and as I already told that we will assume the same value for boundary, which is 25. So what we will do, the average of the boundary and the average of the first isohyte will be P1. So 25 average is 25, so the 25 P1 value will be 25, and the area, this area will be called as A1. Similarly, this 25 plus 30 divided by 2 will be P2, and the area between these two, this area will be A2, and similarly up to the end. Now here are 2 points. It may be noted that the last and first areas mentioned above may be between an isohyte and boundary of the catchment, as already discussed. In this case, the precipitation at the boundary line is required, which may be extrapolated or interpolated. The precipitation at boundary line is not known. Here it is known 25, here it is known, but at the boundary line this is not known. So what we will do, here it is said that it will be extrapolated or interpolated, but the simplest method is to assume the same value as for this isohyte. It is 25, we will assume a 25 value for this one. So let's discuss an example. I think this is the same example we previously solved by the decent polygon method. Now here it will be solved by the isohytal method. So from the isohytal method, from the isohytal map shown in figure below, find out the average precipitation. This is a map, catchment area of this river, and these are the different gauging stations, you know, the points, and in these points different isohytes have been drawn, like isohytes of 25 millimeter, of 30 millimeter, 35 millimeter, 40, 45, 50, 55 millimeter. Now what we will do, we will find out the average precipitation using the isohytal method. For the isohytal method, you need isohytal map, which is already given over here. So what we will do, first we will assume any precipitation for this boundary and similarly for the last boundary. So I think we will assume for the first boundary, we will assume the same value as the first isohyte value, 25. So we will assume 25 millimeter value for this boundary, and similarly for the last boundary we will assume 55 millimeter. Then what we will do, then we will find out the average of every 2 isohytes or the isohyte and the boundary value. Just like for this starting value, for this boundary is 25 and the precipitation value at this isohyte is 25. So the average of these two will be also 25, and then we will find out the area. So multiply this average with this area. So this is P1 into A1. Then 25 and 30, average of the 25 and 30, and then multiply this average with this area. This will be P2 into A2. Similarly, this one up to the last 55 and the boundary, and then divided by the whole area, you will get the average precipitation over this catchment. So the isohytes are already drawn on the topographic map. by interpolating rainfall depth at given station, which is already given. Once isohyets are drawn, the area enclosed between consecutive isohyets is determined either by planimeter or any other suitable, more precise method. So, the area have already been measured in this example. Remember, this area is already given to you in this example. So here in this table, in the first column, here it is given the isohyet value in millimeter. Then what is the value? First is the boundary in 25, 25 and 30, 30 and 35, 2 are given, and the last is a 55 and boundary, as you see in the map. Average isohyet value mean average of these two, the boundary and the first isohyet. So the boundary is also assumed as 25 millimeter. So 25 and 25, and the average of 25 and 25, 25 plus 25 divided by 2 will also be a 25. Like 25 plus same 25 and divided by 2, you will get the same 25. Okay, 25 millimeter. So similarly 25 and 30 is average 27.5. 30 and 35 is 32.5. Similarly, the last is 55 and the boundary is also 55, so the average will be 55. The area between consecutive isohyets, such that the first area, which is between the boundary and the 25, this one, first area is this one area, this is the first area, this area, the second area is again this one, and the last will be this area. Okay, so the first area is 310.53 square kilometer, and the last is 1484.99 square kilometer. So what we will do now, the average isohyet value multiplied by the area, this is the average isohyet value multiplied by this area, will give you volume, such that this is P1 into A1. Similarly, this is P2 and this is A2, P3 and A3. So by multiplying, remember here the unit conversion is very important. Like this one is given is in millimeter, this is in millimeter, and the value of area is in square kilometer. So you will convert the millimeter into meter. So how to convert the millimeter into meter? You will write down here multiply by 10 raised to the power 3 meter, and then multiply it with this one. So for this we will write down 10 raised to the power 6 square meter, 10 raised to the power 6 square meter. So if you multiply these two, remember this is minus 3. When you multiply these two and take a 10 raised to the power 6 cubic meter common, you will get 7.76. Actually the total value is 7.76 into 10 raised to the power 6 cubic meter. Similarly, multiply all these two values to get this, and after multiplication finally add the total area the segmental areas to get the total area, which is 16941.60 square kilometer, same as in the previous example. And the total volume is 699.54 into 10 raised to the power 6 cubic meter. So now the mean precipitation will be what? Will be volume divided by area. So this is the volume, 699.54 into 10 raised to the power 6 divided by area is this one. Again, remember, this is in cubic meter and this is in square kilometer. So to convert it into square meter, we will write down here 10 raised to the power 6, which is converted into square meter. And then finally, to convert the answer into the millimeter, here it is written as 10 raised to the power 3. Okay, so this is for conversion into the millimeter. If you don't write this, multiply by 10 raised to the power 3, you will get the answer in meter. Okay, so this was the first example. The second example is, I think it is just like the previous one, but here it is important to ignore the boundary, the first and the last isohyte, as these are out of the catchment. So example, you can see from the data given in table below, which was obtained from an isohytal map of a catchment, find out the average precipitation of the catchment. This is the data which is taken from the isohytal map of a catchment. The isohyte number. The isohyte number means just the name of the isohyte. This is isohyte 1, 2, 3, 4 up to 8. And this is the isohytal precipitation, the value of the isohyte. Here the value is given in the centimeter. In the previous example, the value was in the millimeter. So the first value, the first isohyte value is 2.5 centimeter, 5 centimeter, 7.5, 10, 10, 7.5, 5 and 2. And the area enclosed between two isohytes, such that the area between isohyte number 1 and 2 is 390, between 2 and 3 is 520, between 3 and 4 is 650, between 4 and 5 is 390, between 5 and 6 is also 390, between 7 and 6 is 442, and the last area between the isohyte number 7 and isohyte number 8 is 546. Now here a note is given. Note that the isohyte number 1 and 8 were out of the boundary of the catchment. So the area between isohyte number 2 and the boundary was estimated to be 312 square kilometer, and data between isohyte number 7 and boundary was 494 square kilometer. Precipitation on these boundaries was interpolated as 3 and 3.1 centimeter respectively. Now here it is a problem in which, let's suppose this is the area, and in this area we have isohyte number 1 over here, isohyte number 2, isohyte number 3, isohyte number 4, isohyte number 5, isohyte number 6, isohyte number 7, and isohyte number 8 is over there. Now this isohyte number 1 and isohyte number 8, these two are out of this catchment area. So we have to calculate all those isohytes which are inside the catchment. We are not interested in these two, so these must be removed. So remember, the area between the isohyte number 1 and isohyte number 2 is given to be 390, okay, which is this total area. This area, this total area is here, but we don't need this area, as we don't use this. We will need the area between isohyte number 2 and this boundary. Similarly, the area, we will need this area. Okay, so this area and the precipitation value of this boundary. Similarly, this area and the precipitation of this first boundary is given in these notes. Here they see here the isohyte number 2 and the boundary, the area between the isohyte number 2 and the boundary was estimated to be 312. This is actually this one. Okay, and similarly isohyte number 7 and boundary, the area was this. This is actually this area. Okay, precipitation on these boundaries was 3 and 3.1 centimeter. Precipitation at the starting boundary was 3, and at this it is 3.1. Okay, so now let's move to the solution. In Isohytal method, we have to calculate the average precipitation of every 2 consecutive isohytes. Every 2 consecutive isohytes by, this is given in table below. Here it is isohyte number. Isohyte number 1 and isohyte number 8 are removed, excluded from the calculation. So the boundary, starting boundary and the last boundary, and the values of these boundaries are given in the notes. So this is 3 centimeter and at the end it is 3.1. Isohyte number 2, 3, 4, 5, 6 and 7, these are included in this sketchment. So these are, so first column is the isohyte name, second is isohytal precipitation in centimeter, which are given, and the third is the average of precipitation of 2 consecutive isohytes. Mean the 3 and 8. The average of 3 and 8 is how much? 3 plus 5 is 8, which is divided by 2 will give you 4. So for isohyte and bound. Similarly, the average of 5 plus 7.5 becomes 12.5, and 12.5 divided by 2 is 6.25. This is the average of these two. The average of these two is 6.5. Similarly, 7.5, 10 is 8.75. 10 plus 10 divided by 2 is 10. 10 plus 7.5 divided by 2 is 8.75. So average of all these 2 consecutive isohytes have been calculated, and these are the average. And the area enclosed between these 2 isohytes is already given. Just this area is taken from the note, and this area is taken from the note, and the remaining areas are already given. So now multiply this area with this average precipitation. So 312 square kilometer multiplied by 4 centimeter. But remember again, here it is the unit conversion is very important. Here it is centimeter, so you will multiply this value with 10 raised to the power minus 2 to get the meter, to get it into meter. And similarly it will be multiplied with 10 raised to the power 6 square meter. So 10 raised to the power 6 and 10 raised to the power minus 2 becomes 10 raised to the power 4, and the remaining value is just multiply these 6.25 multiplied by 520, you will get 3250, and 10 raised to the power 4 cubic meter is taken as common from all. So these formulas are very simple. This is column 1, column 2, column 3, column 4, and column 5 is just equal to the column 3 multiplied by column 4. So this column is multiplied by this column, you will get this value, but take 10 raised to the power 4 cubic meter is common. At the end, summation of these area is 3198 square kilometer, and summation of this is 22260.2 into 10 raised to the power 4 cubic meter. So this summation is actually this one. Okay, the value of this is this one, and this one, the total area is this one. So putting the values 22260.2 divided by this, and taken, remember again here, a 10 raised to the power 6 multiplied by 10 raised to the power 6 comes with this is square kilometer. So if we convert it into square meter, we will write here 10 raised to the power 6. And similarly, you know, here it is 10 raised to the power 4. 10 raised to the power 4. So what will be the 10 raised to the power 4? Will cancel this 6 and remain 2. So when you divide this value with this, you will get 6.96 divided by 10 raised to the power 2, which becomes in multiplication 6.96 into 10 raised to the power minus 2 meter, and 10 raised to the power minus 2 meter mean centimeter. So the answer, final answer is 6.96 centimeter. Okay, last example is, I think it is also the same example, but the only difference is that the data in this example is given in a statement form. So in the first example, the data was given in the map form, an isohytal map was given. In the second example, the data was given in the tabular form, and in the third example, this one, the data is given in the statement form. So the thing is same, just the data is given in different form. So in a catchment of area 1000 square kilometer, the total area of the catchment is given. There are 8 rain gauges, 5 inside the area and 3 outside its surrounding. So total gauges are 8, but we are interested only in the 5 gauges which are inside the area. Isohytes were drawn from the data of these rain gauges for a storm. Okay. From the isohytal map, the following information was obtained. Area between 1 and 2 centimeter isohytes, 2 and 3 centimeter isohytes, 3 and 4 centimeter isohytes, and 4 and 5 centimeter isohyte was 105, 230, 150 and 220 square kilometer respectively, such that the area between isohyte number 1 and 2 centimeter, isohyte 1 centimeter and 2 centimeter isohyte is how much? Is 105. Similarly, 2 and 3, you can see it, make its color same. 2 and 3 centimeter area is 230 square kilometer. 3 and 4 centimeter area is 150, and 4 and 5 centimeter isohyte, the area is how much? 220 square. The area between 1 and boundary, which has 0.75 centimeter rainfall and 1 centimeter isohyte, was this. The first boundary value is 0.75, and the area between the first boundary and the isohyte number 1 centimeter is 120, and similarly at the last the value is 5.5 and the area is 175 square kilometer. Find average precipitation. So the all data we required is given. So just put this data in a tabular form and then make calculation. So that you can see here in the calculation, isohyte number, this is just the isohyte name, and this is the isohyte value. Starting boundary, end boundary, 1, 2, 3, 4, 5. These are only 5 isohytes, remember. Other 3 isohytes are excluded because these are out of the boundary of the catchment. So the value of the isohyte at the our isohyte number 1 is what? 1 centimeter. Isohyte number 2 is 2 centimeter. of isohydrate number 3 is 3 centimeter, of isohydrate number 4 is 4 centimeter, of isohydrate number 5 is 5 centimeter. The value of the first boundary is 0.75 centimeter, it is also given, and the value of the last boundary is 5.5 centimeter. So first we will calculate average of every two consecutive isohydrates. So average of the first boundary and the 1 mean 0.75 plus 1 divided by 2, so the average will become 0.875. Similarly, average of 1 and 2, 1 plus 2 is 3, 3 divided by 2 is 1.5. Similarly, 2 plus 3 is 5, 5 divided by 2 is 2.5. So the average of every two consecutive isohydrates have been calculated in this column. This is the average of precipitation of two consecutive isohydrates. The area is already given. The area between the first boundary and isohydrate number 1 centimeter is 120, and the area between the last boundary and isohydrate number 5 is 175, and the remaining area is already given in order. So what we will do, we will calculate the volume by multiplying the average precipitation with the area. So this is the average precipitation, 0.875 multiplied by 120, you will get 105 into 10 raised to the power 4 cubic meter. Remember, again, this is in square kilometer and this is in centimeter. This is very simple units. If precipitation is centimeter and the area is in square kilometer, you just multiply this value with the square kilometer value. 1.5 multiplied by 105, you will get 157.5, and just write down 10 raised to the power 4 square kilometer directly, cubic meter, sorry, 10 raised to the power 4 cubic meter. So multiply this column and this column, you will get the last column. After multiplication, you can add all these values, so the summation of all these values is this much, and the summation of the area is 1000, which is already given. So the value, putting the values in the formula, you can now that this summation is actually this one, so putting this value over there, and this A is what, 1000, putting this value 3271.25 divided by 1000, you will get answer in meter, but as you know, here you will be remaining with 10 raised to the power minus 2 meter, so 10 raised to the power minus 2 mean centimeter, so the answer of this number is 3.27 centimeter. Okay, this was all about the Isohytal method, and at the end, as usually, I have some recommended textbooks in reading references, and commonly I'm using this first one, K. Subramania, Engineering Hydrology. Okay, thank you. If you have any question, issue or problem in this lecture or in the previous lecture, you can contact me through my email address hasan.seval@sood.edu.pk.